Po-Chu, and this is the demonstration video of the operating system in Lab2. And in this project, we are going to implement the scheduler in the lecture on the XV6 systems. So let's quickly demonstrate our code here. So let's first simply demonstrate the round robin scheduler here. Okay, so in this lab, the parameter we use is that we will distribute 100 ticks to 3 processes, and for each process we allocate the tickets for 30, 20, and 10 for each. And because the round robin scheduler has each equal time slices for each process, so the result will show that for these 3 processes, every process has the same ticks that is distributed, like here. So if we change the parameter to 100 ticks and to 2 processes, and for even we change the ticket really undistributed, and the ticks will also be equal as expected. So we can see here, even we assign a different number of tickets, the ticks will be distributed equally to each processes. So that's basically how the round robin scheduler works. And now we switch to the lottery scheduler. So we change to the scheduler to lottery. So as we know that the lottery scheduler, we assign the tickets as a priority to each process. So if we assign the different numbers, then the tickets distributed will basically based on the tickets they are assigned. So let's try. The same, we have 100 ticks to be distributed to 3 processes, and each process will also assign the 30 and 20 and 10 tickets to them. And let's see the result. Alright, so as we can see here, we can see that we expect that the more tickets you have, then the more ticks you will be distributed. So number 1 process has more tickets, so it got the most ticks on CPU time. And the third process get the lowest tickets. So the CPU ticks got distributed is the lowest. And the other thing we know is that the lottery scheduler is a non-deterministic. So if we do this again, the number of ticks will be changed. Like we also do the same parameter again, and the ticks will be different. Yes, as we can see here, even we put in the same parameters, the ticks distributed will be changed, but the order of the ticks being distributed will follow the ticks that are assigned, because we know the priority is based on the tickets. So the basic idea is that the order should be the same. not being changed too much. And let's try the other parameters, which is the 100 ticks to be distributed to two processes. And as we can see here, we distribute the tickets really imbalanced. So we expected that the number one process will get the most ticks. Right, so as we can see here, the number one process get the most ticks, and the number two process get the lowest ticks. And we can also change and do it again, and the number will be slightly different. Yeah, as you can see, the number will be slightly different, but the order will be the same. So this is the non-deterministic scheduler for the lottery scheduling. Now let's go into the strike scheduling, which is the deterministic scheduler. Let's change into the strike. Okay, so let's do it again. 100 ticks to be distributed to three processes. So as we can see here, we expect the result that the ticks distributed is not only follow the order, but the result will also be unchanged. Let's see the result first. All right. The result typically follow the manual that gave in the Lab2 project, and if you run it again, the result will be the same, which means the ticks distributed will remain the number here will remain unchanged. Yeah, as expected, and the order is also followed. The order of the distributed ticks will also follow the order from the tickets. And if we run the extreme case here, there are two processes. Process one have 19 tickets, and the second have only one ticket. And as we can see here, because the strike scheduling is a deterministic scheduler, so because the process 1 got 19 times tickets compared to the process 2, so the ticks it got distributed is also 19 times, which also follow the expectation result. So that's basically our demonstration, and we can go through the code really quickly to see what's our modifications. So in the system code .h and .c file, we basically add to entry for the system call function call, which is here and here. And for the system process.c file, we need to create an interface to let the user level to enter into the kernel function call. And that dfs.h file is also the same function here. And the main function in the kernel is defined in the proc proc.h file and proc.c file. And in the .h file, we first define the key variables for the lottery scheduling and the strike scheduling, which are the tickets and ticks, and the strike and the pass here. So the proc.c file is basically the main function for the kernel scheduler, like here. As you can see, the lottery scheduler here, and the strike scheduler function is also defined here. And this is the default round robin scheduler defined here. And this lab2.c file is directly copied from the manual. Now for the user file, we need to define the entry here to let the user call the kernel function. And also the .h file, we need to define the user interface here. And one of the most important part in the make file is that we need to define the parameter here to change our different scheduler. And also we need to make sure our Lab2 testing file is being made. And also the most important one is that in this lab, we assume that we only have one core CPUs, so we need to change these parameters. So that's basically our demonstration, and this lab is really pretty interesting implementation because we truly demonstrate how the different schedule works, like the deterministics and non-deterministics, and also the same equal time slices round robin hood scheduler. And that's it. Thank you.